The Build Show Build Boston series is sponsored by Allura Fiber Cement Siding, Mitsubishi Electric Train US, Roseburg, Schuco USA, and Warmboard.
All right, everybody. Steve Basic Architect. We're out here. Build Show Build Boston. Guess what we're talking about today? I know, I always talk about floor framing being exciting and roof framing and insulation, siding, but today, look what we got here. When you start seeing stuff like this show up, we know we're in for a treat. We're putting HVAC in. We're very fortunate today too because we got reps not only from Mitsubishi and the installation company that's going to be doing all of our mechanical systems here, but we also have a couple gents from Zehnder. So we're going to be talking about, yes, all HVAC. For those of you not familiar with the acronym, heating, ventilation, one of the most abandoned terms in the building industry, in my opinion, that it should be one of the things we care about the most. So pay attention when I'm talking to the Zehnder guys, because you're about to possibly learn some things you never knew before. And then of course, AC. With everybody talking about climate change, who doesn't want to talk about AC these days, especially if you're down in Texas, Mississippi, Louisiana. Yeah, you pretty much can't live down there without AC. But anyways, we're up here in the near Boston site, and we're about to catch up with the Mitsubishi reps. So let's get over there and let's start the conversation. We had Dave. Dave, pleasure.
Steve,
thank you for coming up. Now,
thank you.
Dave is the Mitsubishi rep for the Northeast and the Mid-Atlantic, right? You pretty much have the East Coast down to Carolinas, maybe?
Carolinas North.
Carolinas North. Talk about getting some miles in. Yeah, you got your work cut out for you. And it's interesting, too, that being an HVAC rep, that being a rep in Maine is different than being a rep in Jersey is different than being a rep in Carolinas. So unlike the guy that gets Arizona, New Mexico, and Texas, where he's pretty much in the same climate zone, you're like 3 or 4 reps rolled into one.
Correct.
Right? You get to deal with kind of the extremes in all cases, as well as the humidity and, you know, getting at waterfront properties and such. So, but you work for Mitsubishi. You've been a huge help on this project. Mitsubishi has been a dream company to work with. They are one of the sponsors here, but man, their collaboration effort, getting us equipment, working with us, sizing it, making sure that we don't do anything bad, and making sure that we're putting in the right equipment, which is pretty much your job, right?
Correct.
So, I mean, do a lot of builders, I'm always fascinated that, you know, builders I talk to, and I'll say, hey, did you talk to the rep about that? Oh, yeah, I don't know who he is. And it's like all these companies have reps all over the country, and nobody chooses to talk to you guys.
Well, we at Mitsubishi have figured out a little bit of a different way to dice that into our design. So I work with builders, architects, engineers, HVAC installing contractors to build a team to work together so that they're all on the same page, understanding building science really well, and what the capabilities are of our systems to be able to come down to a BTU load requirement that meets the application precisely. So that's what our secret sauce is, our people in the field that has that communication and relationship connections with the builder community in general.
And one of the things I find interesting, and it's probably more pertinent in the mechanical world, is, you know, the post-war era compared to now, Mitsubishi as a company has more choices in equipment than the whole industry had in the post-war era, right? In the post-war era, it was either that boiler or that boiler, right? And now you guys have a whole spectrum of solutions for us, right?
Yeah, the heat pump market has really expanded, that we provide not just wall mount units, but ducted versions or a combination of them. and in any climate zone capability as well. For example, in New England, we have the ability to provide heating down to -13 and even down below that, down to -18 and -22, and still provide heat for those low load homes in particular, but also whole home solutions, wall mounts, ceiling recessed units, low wall mount units of any BTU capacity size, from 6,000 BTUs up to 60,000 BTUs.
And manifold systems that go out, you know, to one single unit outside, so you can have some kind of discretion as to which unit is running when and running the outside unit.
Correct.
For those of you that aren't familiar, I know a lot of people you watching the video might not know, but when he speaks of heat pump, it's an electric powered system. It's not a gas or fossil fuel. And that's hence why a lot of people are moving in that direction these days. And I find that it's not even, you know, to get rid of gas. It's just like this house, a lot of people are moving towards zero energy or battery storage and gaining electricity, because I want to say it's free, but then somebody's going to put in the comments, oh, you have to pay for the solar panels. And I've gone round and round with that. So it's not free, but the energy is free. The components aren't, but the energy is free, right? As long as the sun comes up, I can get electricity if I have the right system. And then if I make that, I can bring it down here, and Mitsubishi, doing their homework, gives me really nice high efficiency units. So I'm using the least amount of electricity to produce the most amount of either heating or cooling.
They really drive that electrification trend that is happening throughout the country, frankly, right now. And being that the IRA money that's being poured into the industry, and how much of that has heat pump in its, one of the three legs of the stool is describing heat pump utilization into the market, our systems are designed to help address that and then to drive that forward into the years ahead.
Yeah, and you have a great team. I know a lot of people on your team, Chad, and people that we've worked with in the past. Always a dream. Now, in this particular house, I believe we have 3 floor-mounted units.
Correct.
Right? We chose not to zone them. We zoned them by unit rather than having dampers in our ductwork to do the zoning. So you typically have the option of putting in one large unit and then just directing the air through the ductwork system via some dampers and oversized ductwork, or large ductwork, not necessarily oversized. Or you can go to multiple systems like we did here and have a system service a certain section of the house, which we can get into later. But we also have the conditions where we're doing a conditioned garage, as well as we have a plant room upstairs. Mm-hmm. Not what you're thinking, just right there. I know the minute you say plant room, comments go off the charts. But I didn't say grow room, plant room. The homeowner is a hobbyist arborist. But with that, and again, working with a company like Mitsubishi, we can solve it by having these floor-mounted systems in the basement. But in the plant room up there, we're doing a wall-mounted system. And then in the garage, we're also doing a wall-mounted system. So we have switched systems, but we stayed within the company.
Well, actually, the plant room is going to be a system of an evaporator that slips up in between the ceiling joists. So it takes that unit off the wall, giving more room for decorations, aesthetics as he wants to do, but provide all the comfort that's necessary for that room as a separate zone, individual, off the, separate from these systems completely.
Right, right. And then in the garage, there we'll have the wall mounted. I forgot,
Correct.
Yeah, that when we're doing the ceiling mounted system. We actually just did a project where we installed those, and I mean, they pretty much disappear quite nicely.
Yes.
One of my pet peeves, I got to tell you though, with all wall-mounted systems, they've been out for, I don't know, we've probably been using them for at least 12, 15 years, probably a little older. Guys got to come up with some aesthetic choices there.
Working on it.
The performance is great, but man, we need to see some that disappear a little bit more, because I could sell truckloads of those if we made them just a wee bit nicer to look at, because some people's hang-ups are, what does that look like? But anyways, we're going to have one here in the garage. It's going to condition the garage just nicely. We have these high-performance units down here. We're going to catch up with our mechanical contractor. Any parting words before we jump over and start talking about the system?
It's been a pleasure working with you and the Build Show in this Boston project, and also Scott Rodman, the homeowner here, has been great in helping to design the system to his liking. We've been able to customize it and figure what he wants for comfort he's going to get.
Great. Yeah, so let's jump over. We're going to catch up with the mechanical contractor, and we're going to talk about exactly what we're doing down here. You're free to join us, Dave. Let's head on over.
Great.
Just making sure we're catching my good side for this video. All right, so we're over here. I know we're going to walk over there and we're going to talk about the actual units and the install, but I think before we get over there, we come back here to square one. I got Bryce here from Chris Johnson Electrical Mechanicals. They're a mechanical contractor here. They're going to be responsible for the installation of all the mechanical systems, ductwork, as well as all of the radiant floor tubing, right? You're going to be putting that system in
yes.
also. So how you doing today, buddy?
Good, how you doing? Nice
All
to
right.
meet you.
Yes, yes. First time meeting Bryce out here on the job today. I get to meet a lot of really cool people doing what I do. So, and a lot of smart people that just really understand what they're doing. I'm always amazed that, you know, a lot of architects will just kind of walk on site, go do their thing, and then just walk off site and not have conversations. I can't tell you how much I've expanded the spectrum of my knowledge just by coming down and saying, hey, how are we doing today? What are you doing? How do you do that? How does that get installed? And getting that information that then I can help make me some decisions so that I get an understanding of, hey, the next time we're doing a house like this, yeah, that duct should be about this size for this reason. And then I have some feedback to then complete my work intelligently. So I don't give a set of plans and just say, well, here you go, you figure it out, it's your problem now, right? So we got a team here. It's a great team. We just talked to Dave from Mitsubishi. They helped us out a ton, but then they turn us over to Chris Johnson, and Chris turns us over to Bryce. So here we are. This is where the rubber meets the road. So let's talk about it. We got a ton of supplies here, Bryce. You guys show up and just stuff starts appearing.
Yeah, we kind of get a truckload of stuff that looks a lot like this. Mostly it comes in this standard raw form, just two sides. And this will be used as your supply ductwork, your return ductwork, and that round, unless it's in an attic, will typically be used as the actual branches that come off of the main run.
So this typically square duct is associated with, say, the highway.
Correct.
And then this, to use that, complete that analogy, this is kind of the feeder streets to the highway or off of the highway, right? But this is the highway. It comes in an L-shaped leg here. Now, I notice it has two edges. One has this kind of seam or double hem here that has a space in it. And then we have this one here that has a series of dimples on that, right?
Yep.
So I'm assuming that these just snap together?
Yeah,
like
you just kind of line them up. And then typically with a hammer, or if you got really strong palms, you just go ahead
just
and
pound that in, but then we end up with that whatever size duct we call for. And I'm assuming at your supply warehouse, you can get these legs in pretty much any configuration, right?
Yeah.
Like a 6x8 or 8x8, 6x12, whatever the ductwork is being called for, you get that. Now, I see this stuff on a lot of stuff. This is simple insulation wrap that I see on most of the ductwork that gets installed.
Right, yeah, it's just standard bubble wrap. It has a spacer in the middle, and this equivalates to 8 R value.
An R8, okay. Yeah, by capturing that air, and you can see we have the square duct there, but we also have one of our feeders here, and you know, it's always great working with professionals, I'll tell you. You can see the seam is nice, tightly fitted. This has been folded back, so it's ready to get installed.
Ready to go.
It's not sitting there and saying, oh, let's pull this back and tear it or figure it all out. It's ready to go and ready to get installed. So yeah, fabulous job. And all of this stuff gets fabricated down here, gets wrapped down here. So you basically just set up a small little workshop down here, and your first few days is putting a whole bunch of stuff together.
Correct. Yeah, first few days, getting the units in place, getting them on the plenums, ready to go, and then going around mapping out the supply registers, the return registers, and figuring out, you know, how much we're gonna need and what needs to get wrapped and where it's going.
All right. Well, I know you got some ductwork installed. Why don't we just take a walk over here and we could check out some of your work, what's happening down in here. So, we have our Mitsubishi heat pump here with the blower. That sits on top of this configuration here. Now, in our conversation earlier, you were talking about this is just something you buy, right?
Yeah, that just comes standard from the supply house. We can get them in two different sizes depending on the size of the air handler itself and the size of the return that needs to come off of the air handler.
Gotcha.
So this is a smaller unit. We got the smaller box, and these come standard with the ability to fit a MERV 13, 15, 18 filter right inside of it.
All right. So that box down below is actually, I see it as doing like 4 different things. Obviously, it becomes the base for the unit, gets that off the ground. It becomes the return plenum. That's this side here, the air coming back from the house. It goes down through there. Does this just pop off?
Yep, this will just pop right off.
So that just pops off, and then you get quick access to that filter there, but then it's also sitting in a drain pan. So if we had any kind of leakage or any moisture accumulation associated with this, it's all gonna go into that pan and be contained there.
Correct. And what we also do in installation when we get further along in the project is we'll put a float switch in the pan. So if there ever is a leak, that float switch will detect the leak and shut the unit down completely, so no more water will be generated.
So if I wanted to mess with Scott, I could come down here with a bucket of water, just fill up that pan and shut his system down and get him quizzing on what the hell's going on down here.
Yep.
But so let's talk a little bit about ductwork.
Sure.
I mean, we have a whole maze of stuff happening here. You know, I obviously have seen a number of systems. The supply system is the one that usually comes off the top of the unit.
Correct.
The return system is usually either going into a side of a unit or it's going down below. You know, it's funny, in the southwest where I did it, we would have some systems where we would go down into the floor. So this would go up and turn over and go down. Do you ever hear the term called pair of pants?
Yep.
Yeah, so we called it a pair of pants because
wow.
it turns around and now it looks like 2 legs getting split there. But so the supply goes up and then it feeds into a larger trunk, and then the larger trunk diminishes in size sometimes as you go down because you're trying to maintain a certain pressure
Correct.
inside that system.
Correct.
Right?
Yeah, we reduce the size as we get further away to maintain that the desired CFM based on the size of the unit. And in doing that, you know, we'll also determine where the supplies are coming off. If you have 3 supplies in one area and 1 supply down where it's reducing, you're going to find a decent amount of air loss. So we try to, you know, equally distribute, you know, where the supplies are going and where it's reducing as well.
Right, and now I notice here, as this goes up, we have one of the leg comes over here, turns, and goes to the end. Now, it's always, you know, an interesting point to understand that you never want to have a duct coming off of the end of the duct. Right?
Correct.
And I learned this a long time ago by a really great engineer out of Colorado, but you know, we were sitting around at lunch and he was quizzing me, and I was learning stuff, young architect, and he was saying, you know, out of all of these pipes, here we have 4 pipes, and as that fills up, which one of those pipes fills first? Right? Mm-hmm. Now, most people would say, okay, the air is going to go all the way to the end, then it's going to back up, and then it's going to go in there. But it doesn't. It hits here, and it has the back pressure, that whole duct, until it starts filling the first duct.
Right.
and then it goes down the line and finishes with the last duct in line, which I always thought was a little bit different than what I would have thought was happening there. But
Right.
he was a really good engineer, so I trust him. Now, I see a couple things as these things come off. One, we have these little twisty things in here. What are we doing there?
So those are manual dampers. Those are used to open and close the airflow to that
Okay.
particular takeoff. So if the unit is balanced or unbalanced, those will be used to supply more or less air.
So at some point in time in the future, the system's going to get all installed.
Yep.
Then we're going to turn it on. This particular register might be calling for, I don't know, given that size, let's say it's 110 CFM.
Okay.
And we're going to go up there, we're going to test the flow coming out of that register.
Yep.
If that flow is, say, 130, then we're going to be able to take this, and you can see, I don't know if it turns that damper, but
Yeah.
be
Yeah.
calling up,
You
but-
can turn it now. There you
it's
go.
turning. But you can see that damper. So that damper now, we can go up there, keep the flow meter on that, modify the position of that damper, and then tune that from that 130 down to the required 110, which means it's going to take that 20 CFM and push it somewhere else.
Right.
So
right.
we have to jump around the house and make sure that all of them are somewhat comparable to their design flows.
Right. Right.
So now, one other thing that I realized here in looking at this, we have a straight pipe. We're going to use the one up in the joist bay there as the example, but about 4 or 5 feet from the termination, it seems like you switched to a flex duct.
Yes, we did that. Well, by code, we are allowed 5 to 8 feet of flex.
Okay.
And so we do it for that reason. It's a little bit easier at the end. In this aspect, it wouldn't really matter that much because it's a straight shot. But here, it works and help keep down noise. So, it'll be a little bit quieter when the air is passing through here. But it is definitely very useful if we have, some tight radiuses that we need to get around.
Yeah, I always had it explained to me that, through the straight pipe, which is what we have here, that's a hard pipe.
Yep.
That some people would call. The air moves very fast and very straight
Yes.
through that system.
Yes.
The minute it hits the flex, because of the profile inside there, and I don't know if we have a piece
Yeah.
available here, a piece of flex duct. Because of the profile inside here and the fact that it's corrugated and has all of these ridges in here, the air kind of tumbles once it gets in here. So it kind of slows it down,
Right.
builds up a little back pressure, but you have to keep it. Maybe you know exactly the number, but there's a certain velocity out of a supply register that is within range of being, let's say, comfortable,
Yes.
right?
Yep.
Because at some point, if you push too much air through that system, it's going to start whistling or humming, or
Right.
you're going to hear, because it's just too much air for that size of the hole, and it's
Right.
being forced through at a higher speed or higher velocity. So you want to get that down. And the same is true for returns, right?
Yes.
When you size a return grill, you want to size it appropriately for the flow, but you also need to understand what's the velocity of air going across that grill, because you don't want it to be too high, because then you're going to hear that,
Right.
again, whistling, humming, and all of that noise. This probably also helps just because of the lined insulation and such here. Also, it helps with the acoustics of the system there.
Right.
And in that finishing with that, it makes the whole system just a little bit quieter.
Right, correct. Yeah, that's essentially what we go for when we're doing the ends and just flexes. And it's actually the opposite if we were to run the entire run in flexible duct, it would completely diminish the airflow, and you would get pretty much whispers out of that vent.
Right, so our dedicated 110 or 120 CFM might in fact only be 70 or 80 CFM if we ran the whole system in flex duct. So there's definitely a science behind this. And I'm
Right.
sure you guys have a whole section of people that do nothing but size and think all about all of this before you get out to the job site.
Correct.
Right? You don't want to get out to the job site here and be guessing at how long things should be and,
Right.
and what size things should be. They should be all planned out for you.
Correct.
I don't know, anything more that we should talk about with the HVAC? I got one point that, that I can make clearly here. One of the things I like to do as an architect, I tell people I always divide the basement into two spaces. I call this the dirty basement, and I call that the clean basement. And the dirty basement to me is all of this, right?
Yeah.
The dirty basement has the ability that if something wants to come below a floor joist, it can in the dirty basement. But in the clean basement around the side here, things are restricted to only the joist base
Right.
there. And, so I'm a little particular about that. But it also is part of the planning on my part so that when you see over here and you look, the finished room, I still have a little 3-foot hallway here so that all these systems can get from this section of dirty basement to that section of dirty basement. And a little bit of pre-planning means that we don't have any soffits
Right.
in that room, and that room can stay really nice and clean. And given the fact that it's the media room, we don't want any soffits and all of this stuff hanging down. We want to make sure that our clients are getting the best possible job that we can give them. So anyways, all right, well, that's heating and that's cooling. We have both in here. This has the capacity to do both. So it's going to provide our air conditioning, but it can, even though we have radiant floor heating, we can turn this on at any point in time and get heating out of it also through the whole system. It's not any part of our ventilation system. We got that right next to you here. I'm going to grab those guys. We're going to talk a little bit about the ventilation system, but we'll be sure to return here when you're wrapping up and doing all the finish, and we'll turn this baby on and see what we got going.
Awesome. I'm looking forward to it.
All right. Well, you have a great day. I'm going to go catch up with the Zehnder guys.
Alrighty. Thank you.
So this is the Zehnder ventilation part of HVAC. Yeah, that's Larry hammering over me. I asked him to do something. He picks the loudest activity possible. For those of you out there, we're going to be talking about ventilation. I got my good friend Zabi from Zehnder. How you doing today, buddy?
I'm doing great, Steve.
He's doing great. So, with ventilation, all of you naysayers out there, oh, we don't need it. You don't want to build a house too tight. I'm going to stand here and I'm going to give you my position. I can't build a house tight enough. If I could build a hot air balloon and make it zero air leakage, I would be the happiest architect on earth. Haven't gotten quite there yet. We've got some really low numbers, but we haven't gotten quite there yet. But today we're going to talk about the conditioning systems, but we're also going to talk about how we resolve building a very airtight house and actually making it more healthy than if we didn't have an airtight house. So Zabi works with Zehnder. Zehnder was our ventilation system of choice here. The reason I really like Zehnder is it's one of the few systems that has the widest spectrum of distribution. And what do I mean by that? Every room gets touched with ventilation in a Zehnder system, as opposed to, say, dumping it into a large room and letting the house handle the distribution along the house. So, Zabi, we worked with you for, I don't know, a couple months now. You've done the layout on this. Talk to me a little bit about Zehnder, why you think Zehnder is always the right choice, and how do you make houses like this successful and make guys like me look good? I know that's a challenge,
So,
because I can hear by a little chuckle.
Steve, the main point, what you made already, our distribution is not dumping the air just to the central ductwork or central HVAC distribution system. We are actually moving the air across the entire construction. That means that we're concentrating to extract the air from certain rooms where the air could be contaminated with smell, chemicals, dirt, or anything. We're talking about bathrooms, kitchens, laundry rooms, storage spaces, and we're putting the filtered fresh air into the living quarters, living room, dining room, bedrooms, where people are technically sleeping and spending a lot of time. We have transition zones where we not necessarily need registers, but the air moving through because of the pressure difference. We're sucking from one section and pumping on the other section, so the air moves through. And that's what makes us different than most of the competitors, because we giving a full solution to put the distribution into the house and move the air across with quite highest efficiency on the market.
Now, it's safe to say you're a firm believer in Zender. Everything you just said, totally agree with. The one analogy that I like to make that I think it makes it real easy for people to understand is, you know, we sit here, stand in there, lay down in there, wherever we are, we're taking breaths of air. We're replenishing our bodies with fresh air. We're exhausting bad stuff.
Yes.
Well, the Zender's doing that for our house. If we build a really nice tight envelope, the Zender system is taking outside air in, it's conditioning it however we need to condition it, it's distributing that air, basically taking a breath, and then meanwhile, we're exhausting bad stuff, like you talked about. All the bad stuff is odor control, humidity control when in the shower systems, and all of that. And Zender has done a really nice job of understanding that not all the spaces inside the house are the same, right? And that's part of your design. You're the lead designer for Zender. When you send Zender plans in to get their review and their plans, it's going across your desk.
Correct. So as you mentioned, I call Zender as a lung of the house.
Yes.
You breathing through the system. When you submit any request to us on a new construction, first of all, we take a look on the building, we calculate how much is the total volume of the building, and we take a look on the local code requirements. It's important to meet with codes. So as we know, the new 2018 or 21 code has certain extract requirements in bathrooms, kitchens, and other areas. If we're going to FIAS or any other organizations, they have different requirements. So we have to meet with their needs, and we matching up on the supply side to be sure that we're moving enough air into the building. As you mentioned, the beauty of it, with our system, you can eliminate the bathroom fence, less penetration through the building shell, because our system takes care of the humidity and the moisture from the bathrooms, or the smell as well. So there are so many options what we can offer. We have different sensors what you can attach to the system. You can attach a CO2 monitor, you can attach a humidity sensor, or we can work with any 0-10 volt third-party sensor company. We can set up our system, and if needed, because the air quality is going downhill, you have a party, more people, or you have any contamination, the system takes care of it. It ramps up, breathe faster, breathe more air, like when you're running and you need more oxygen, and it takes care of everything without a touch.
Yeah, you talked about the bathroom systems. I mean, one of the things that I've always appreciated about Zender is that not only did you guys create a ventilation system for the house, but you paid specific attention to the fact that some areas require more ventilation than others at certain times. Like the bathrooms will have a ventilation extraction port in there, or exhaust port, but you also have a boost button.
Correct.
So that we can ramp up that extraction and make it higher when we're doing things like odor control or taking a shower, and make that bathroom work a little bit better for us than, say, other areas like bedrooms or
yes, sir.
And such. So, yeah, I mean, I can't say enough about Zender. I love working with you guys. Right from the design part, the communication that we have had, the layout that you guys do, and I realize that, you know, the layout on paper doesn't always match with what we're doing out on the job site, and that's why we're here today. So I suggest we get going, let's walk through the house, we can walk and talk about some of the areas of conflict and how we could potentially solve them.
That sounds good to me.
So Zabi and I jumped upstairs, wanted to have just a really quick moment with you to understand a little bit about construction, sequencing, construction challenges, solutions, all the above. right? So Zehnder, one of the pieces of equipment is this 3-inch ComfoFlex. This is what gets snaked around through the house. This is basically the artery or the highway that the air moves through the house that we use for exhaust and or supply, depending on the room, the situation. But the challenge is, even though it's 3 inches, fits very nicely in a 2x4 wall, sometimes we get behind and the electrician gets in here before us. Now, in a perfect world, we would have had this installed, the electrician would be moving his wires around it, but we don't necessarily live in a perfect world. We have to take, you know, the times and the sequencing sometimes of when people are available. Hey, I can get my guys in there. Can we run, you know, through the bedrooms and stuff? And then we'll work around it and solve for it. But you can see the electrician ran their wire. They have to run it, you know, pretty much in the middle of the stud, so we're not driving drywall screws into it and creating a problem. But the issue now is if we wanted to bring this up the bay, we really can't because we have that wire in the way. But Zabi and I worked out, and I'll let you talk about the solution there, Zabi. So
we have to live in the real world. And in this case, in this room, there's only one bay, what we found, with no wiring and no plumbing. So originally we marked out the register in a different spot. We talked through of it. When we came here today, we're just looking, electricians were here yesterday, we're looking the wiring. Holy moly, only one bay.
right.
This is our solution now. So we have a new mark for the new register. And what's going to happen, 2 3.5 inch hole, 3.25 inch hole will be drilled here through the bottom plate. And this 2 flex line will run from the basement up in this cavity to the register.
Yeah. Now, I realize that some of you might think, okay, hey, you guys made a mistake and now you're just going to throw it in the corner. But there's actually a brighter side to this story. You know, one of the things that I don't like, and I learned early in my career, is when you're dumping ventilation into the air, into a room, you don't really want to dump it out over the bed. For most people, it wouldn't matter, but for some people that are ultra sensitive, they can sense that temperature difference in the air that's being delivered to the air in the room, and they don't like the idea of, hey, I'm feeling cold or I'm feeling warm, basically the opposite of whatever the temperature is in the room. And like I said, it's not everybody, but there are some people that I've run into that are that sensitive to it. So putting it off into the corner really doesn't bother me in that it's going to dump the air into the room and give that air some time to temper and mix with the room and the air before it's really felt by the occupant in the room. So it's one of those things that, you know, as an architect, builders, and all of our sub-trades, we just have to work through. But, you know, the idea is that when we find these challenges, we find that bright end of the tunnel, right?
Yep, we figure it out.
All righty. So there you have it. Crisis averted. All right, so remember, HVAC. We talked about H, we talked about A, we talked about C. Can you give me a V? V is for ventilation. You guys are in for a treat today because not only are we talking to Zehnder, we're talking to Larry from Zehnder. Yeah. So, if you're all wondering, it's my new friend Larry from Zehnder. What's up, buddy?
Good to know you.
And I told Larry, I said, hey, can you get out a couple things so we can talk about it for a video? Yeah. This is what I call a ventilation buffet, right? He went and got every conceivable part. Do we have any Zehnder screws? No?
We don't need screws.
We don't need screws. See, good answer. It was a test, you passed. All right, but we have all the components here. So we're gonna run through a whole bunch of things here. Everything Zehnder. We're gonna go over, we actually got one of the units installed, so we're gonna jump over there, we're gonna check it out, and we're gonna talk about the ventilation. And then that'll complete HVAC. I know I keep repeating that, but man, some people just forget about ventilation. Everybody likes the heating guy, everybody loves the AC guy. Nobody cares about the V guy, right? But I'm here to tell you, I care about you. All right, Larry, so talk to me. Ventilation systems.
Well, first off, in a traditional house, ventilation was pretty much a bath fan that you'd turn on intermittently, or a ceiling fan, or an exhaust hood in the kitchen. But ventilation in a high-performance house like this is not really a luxury, it's a necessity, because this house has to breathe. So we have a system that's very unique. We extract air from bathrooms, kitchens, laundry rooms, and other places where odors, chemicals, or moisture are created, and we put it back into living spaces. So that's, in a nutshell, we are balanced ventilation, and our system is dedicated with its own ductwork system.
All right, well, I'm gonna help your sales pitch out. So you talked about exhaust systems. A lot of people use exhaust systems, and I know a lot of people do that. Oh, I don't need to put in ventilation, I'll just turn on the bath fan and I'll run it all day. Now, while theoretically that might work, the problem that I have with it, and that I believe you have with it, and what you should have with it, is the minute I turn that bath fan on, yes, I'm throwing bad stuff out of the house. Or in fact, the stove fan, right? When I turn that fan on over my stove, it's getting rid of bad things. The problem is, where is the air that's replacing that air coming from? And what nooks and crannies is it being filtered through? And what type of air quality is the house now getting when I turn that fan on? So, question to you out there, Joe homeowner or Josephine homeowner, I cater to both. Did you catch that?
I did.
All right. So when you turn on the bath fan and that air gets filtered through the edge of a dirty carpet, or the carpet under a door, or through fiberglass insulation, would you rather breathe that, or would you rather have a switch get turned on and have outside air come in through a dedicated port, go in through a filtration system, and then get distributed throughout the house at every conceivable location in low volume, basically shaking it up. And while it's doing that, at the same time, it's extracting bad air, balancing out the house, and getting rid of that bad air. Which scenario do you want in your house? Hopefully you're not voting for the bath fan, because we're here to talk about the latter. So, mechanical ventilation. I agree with you. Every house should have it. I know a lot of people say, oh, a house needs to breathe. It does. This is my set of lungs, the Zehnder system, right? The air comes in, it gets filtered, and then I put it to use, just like my body does. So, let's talk about step one. We have outside air coming in, inside air going out. I see here, this is one of the vents that you have. These are one of the exterior vents, right?
Right. There's a protective coating on it. Normally it's a brushed stainless steel. So.
Right. And that these, the rule on these is that the intake and the exhaust need to be about 10 feet displaced from each other, correct?
Just so you don't short cycle dirty air to clean air.
Right. I call it re-entrainment, short cycling, just another way to say it, right? So you don't want to be pumping bad air out here and then sucking it in, 3 feet down the corner where you're just pulling that bad air that you just threw out. So we want to make sure. So we bring that in. That air comes in through an insulated tube, right? Does this have a specific name?
We call it Comfo pipe.
Comfo pipe. And Comfo pipe, it's made out of a foam. It's a very rigid foam. It's hard. You're not
resilient.
Not crushing this. And it's made that you can see here. It has the male end here, and it has some ridges on it, and then it has the female receiving end here. So they basically just connect together, right? And then obviously, we can probably cut this to any length that we needed to. It's easily cut. This is what, about an 8-inch diameter?
That's 160 millimeter, which is 6.3 inches.
6.3 inches, okay.
Which is good for somewhere around up to about 300 cubic feet of air per minute with no noise, absolutely no noise.
Right, and the insulation probably helps acoustically damper some of
And it also prevents condensation when it's reaching the dew point when it's cold outside.
So that air is coming into the system. It comes into my unit. The unit, I have a choice between cores. I could do an ERV or an HRV core. You want to give us the lowdown on it?
Sure. In a climate like this, which is Boston,
Climate Zone 5.
we have primarily, this is a heat dominant climate, but even so, an ERV will move latent energy as well as sensible energy from one side of the equation to the other, this bad air leaving, we will extract the energy from that air and the fresh air coming in. If it's a high humidity, the ERV core will actually transfer the moisture from an area of higher concentration to lower concentration. It's about 78% efficient on that latent side, which basically means that 78% of the moisture that is outside on a 90% humidity day will be rejected and go to the outside airstream. So an HRV is more applicable for a high mountain desert climate like Colorado or New Mexico, where you're sometimes dealing with humidity levels in that 2 and 3% range. So whatever the humidity is outside is what you're going to be bringing into the inside, and it's really not a nod factor. In our climate here, we would prefer that the air conditioning and heating system control the humidity, not by bringing in pure humidity from the outside.
Right, right. And the ERV also in our climate, it has the ability to strip the paid for energy off the exhaust air and dump it on the incoming air. So if you can imagine, we have 70 degree inside, it's 30 degrees outside, that's a 40-degree delta. As it goes across that unit, it strips the heating that I paid to warm my house off of that exhausting air and puts it onto the incoming air and boosts its temperature. Now, it doesn't immediately boost it up to 70. There's some losses across that transaction, but it's better than dumping the 40-degree air in the house.
So the Zehnder losses are, on a typical day, if you stay within the parameters of our airflow, and we know that the indoor temperature should be somewhere between 70 and 74, we're about 92% efficient. On a lousy day, we're about 85% efficient. I mean, 10 degrees outside or below.
Right.
So we're really saving you a tremendous amount of energy compared to a bath fan scenario.
Right, so at say a 40-degree delta, our losses are probably somewhere in like a 7-degree range.
Oh, it won't be that much.
Yeah.
It'll be probably 2 or 3 degrees.
Okay, all right. So yeah, so it's definitely worth having that system. So we get filtration, we get energy recovery, we get the moisture recovery from the system. It comes into our unit, we make that exchange, bad stuff is going out, the good air comes inside, it goes through our unit, but before it goes to any of the rooms, we have to transition from the large unit to smaller pipes so that we can distribute it and snake it out through the house.
Right. That's where our air distribution system, this is a proprietary air distribution system. We have different sized, we call this a silencer and attenuator, kind of analogous to a plenum in a furnace. Air will come in through the large side here, that larger pipe.
Right.
We mount that in there, and then we have an air distribution manifold. This is an 8-port manifold. These are not installed right now for the sake of this conversation.
No, but all of these 8 ports, and we'll go look at it because we have one installed there, but these basically just lock in on there, and so we have these 6 there, and if we needed more, I know in some houses we have multiple boxes.
Yeah, we have multiple in this house, but we sell it in a 4, a 6, 8, a 10, and a 12-port manifold. So depending on how many bedrooms, bathrooms you have, we can accommodate that.
Gotcha. And then, so connected to these ports is this proprietary Zehnder pipe, right?
That's correct.
And you guys have a name for that.
We call that Comfo Flex.
Comfo Flex, because it's basically a flex duct, and you can see here, I mean, this thing can get into a pretty tight radius, and it kind of accordions up, but making a mess of your buffet table here, Larry.
That's okay. There's a wire that's in here, and it's very strong, impossible for me to squeeze it with my hand.
Right.
So it keeps it patent, so you have air flowing through it.
And the dimension on this?
It's 75 millimeters, which is about 3 1/4 inches.
About 3 1/4 inches. So the beauty of that is we can snake that up through a 2x4 wall, which
Exactly.
I'm sure was the intention.
That
when
is
this
the
was
intention,
designed.
yeah.
If you're going to sell in America, we've got to be able to get it up a 2x4 wall.
So I want to mention something. Oftentimes, I've been doing this 9 years with Zehnder. Oftentimes, people will say this is restrictive, and you're not going to get enough air through it. Our design on this is 12 cubic feet of air per minute on medium speed, and about 18 cubic feet of air per minute on high speed. I can run 60 feet of this and still get my 18 to 20 CFM without any noise, and it's non-restrictive. I mean, I shouldn't say it's non-restrictive. It's considerably less restricted than if we were trying to get 100 CFM out of this.
And one of the things I think people need to realize is we're not dealing with a heating or cooling system here, where we're pumping 120, 150 CFM to a register. At best here, I think the highest room is probably like 36 CFM, right? And so that we would have 3 individual pipes, and then those pipes go to a termination. This is a wall mounted termination. So it basically gets attached to the wall. This is where the diffuser.
We can, if you want to take off the protective coating, that's just to keep drywall mud and dust out. And then after drywall, and our stuff is all friction fit. Here, I'm gonna use this other one. This is the supply side, and we'll pop that in. And imagine that was hanging in the ceiling or on a wall.
On the wall.
And this is an adjustable diffuser.
And just simply by dialing it, you can open or close it, but this has 3 ports. And in some cases, I mean, you have a dual port and you have single port systems
Correct.
also. So depending on the layout, if we get called for 3, this goes up, we get 3 pipes, we get 36 CFM roughly through that system on the supply side. So you guys have pretty much, one of the things I love about Zender is you've pretty much accounted for every scenario. I mean, I've installed, I don't know, probably 30 or 40 of these systems by now. And I can't recall one time where we said, you know what, Zender never even thought of that, right? Like everything has been installed. The other thing that I'll credit you guys have a really great video set up online that a lot of the builders I work with, they just simply go on, they watch the videos, and they install the system themselves. Because like you said, most of this stuff is friction fit or has these, little locking devices that just slide down onto the system there to hold the pipe in place. It's really an ingenious system from a installation perspective. You can go watch a video and then pretty much anybody can do it and snake it around the house with proper planning. And talking about planning, just like our friends out at Warmboard, we send the drawings to Zender and we get a full layout. We get all the flows to the rooms, we get register locations, unit locations, supplies, exhaust. You guys are the consummate collaborators. So what I'm thinking is, why don't we jump over here? We got that system up on the wall, installed. Maybe we pop the cover off. You give us a little internal look
Absolutely.
at what we're talking about there, and we'll wrap it up over there.
Okay.
So let's head on over. All right, so Larry, here we are. We got a unit on the wall, installed. Who'd have thunk, right? But tell me a little bit about it. For those of you not familiar, Zender, that's how you spell the name, Z-H-N-D-E-R. Zender is from?
Well, based in Switzerland. We have offices here in the United States in Hampton, New Hampshire, and our manufacturing distribution is in Buffalo, New York.
Buffalo, New York. But you just told me a pretty little tidbit of exciting news, right? Since 2020, you guys have found a number of vendors here in America where a lot of your components are now being manufactured.
That's correct. So we have moved over 40 SKUs components to manufacturing in the United States manufactured with United States sourced materials. This particular unit is assembled in Buffalo, New York, and we look forward to in the next year or two that'll be 100% manufactured in the United States.
Here. Yeah, and I mean, it's one thing to say, okay, yes, made in America, I get that. But from an architect and supply chain, and from you being the manufacturer's rep, it must be somewhat relieving knowing that all this stuff is getting made here. It's getting made in bulk. You're not waiting on a container of ComfoTube or registers or something coming from Switzerland or from Europe, right? That stuff is here readily available. So it's probably
Indeed.
made your life a little easier.
I think Zender will always be a global company, and we're recognized as that. However, assembling is a good place to start to bring to the United States so we don't have long lead times. Some of our competition have talked about year-long, over a year, especially in the semiconductor world, which we have that pain also. What makes this so unique, this is really the flagship of, there was a kind of like the Wizard of Oz going from black and white to color. This Q series has 4 intake and exhaust from the outside and supply and return to the rooms. There are 4 sensors that measure temperature, relative humidity, and pressure, one in each of those airstreams, yielding 12 data points. We have a microprocessor in here that massages those 12 data points so we have balanced ventilation, and we control something called free nighttime cooling with a bypass damper. So they are all being manipulated based on those 4 data points from each of those 4 airstreams.
So I like to say it has a brain,
It has a brain and it is
right? So
always
it's
working.
doing some thinking. It brings in the air and it's thinking about, what do I do with this air? Do I just let it go? Do I run it through this core? It has some options, and it's always making the best options possible so that when we're getting that supply air, I won't say guaranteed, but we're in a really good light of getting some really good filtered air and air quality.
So if I could, I'm going to open the cover. This is the interaction where it has the display with all kinds of different parameters, dozens of parameters. But this particular side here has a filter that is the air coming from the outside. And right now it's nice and clean. And this will be a MERV 13 filter. And this will bring it down to the pollen, dust, dirt are removed. And then once the air has gone through a heat exchanger.
And that's this inside. This is the inside air port. So that air immediately, the first thing it sees is that filter.
That's correct.
And the exhaust air on the backside here obviously doesn't need to get filtered because we're throwing that out.
That's right. This is a secondary filter that keeps, actually, it protects the core, which is the heat exchanger where that magic happens. And that's really what makes Zehnder so unique, is it's our intellectual property. That core is a membrane. It's not just a heat exchanger, but it's a membrane that moves moisture from one side to the other. And in a second, we can take this open and I can show you the core and what really makes us so unique.
I know it's just a little bit, but I can't tell you. I love companies that think about, okay, we have documentation. Let's create a little pocket here so it never gets lost. And it's always with the unit, right? It's just, it's such good design and good planning to have everything right there at your fingertips. So you think we can maybe pop this off?
Sure. This is a Torx wrench. We don't recommend using Torx to put it back together because you could
We'll find out later.
you could damage the unit.
I'll hold on.
Thank you. But I don't mind using a power tool to take it apart.
Haha, we're sitting behind the curtain.
So this is a very unique heat exchanger. It's what they call a counterflow cross-flow heat exchanger. So imagine thousands of channels running east and west, and thousands of them running north and south. And if you look inside there, you see those holes.
Yeah.
So we have all
I'm gonna
4
turn that to the camera here.
airstream that come in through there, and then this happens to be an enthalpy exchange, or an ERV core.
Okay.
We have an intake fan, we have an exhaust fan, and we have bypass dampers that will manipulate mixing outdoor air, but all air is always filtered in our unit.
Always filtered.
This typically, on medium speed on a house like this, will only use somewhere in the neighborhood of 15 watts of energy. On high speed, it could go a little over 100 watts of energy. Our competitors use 4 times the amount of energy, and that's attributed to how large that heat exchanger is and how we've designed the ductwork to be in this home run system that we use instead of a branch and trunk like a traditional heating cooling system.
So what you're saying is, for pennies, I get really good air quality.
This system will cost under $150 a year to run, and you not only have the comfort and of even climate. Every room in the house will be about the same temperature because we're always moving air, but you'll have the best indoor air quality you can, and that really is our claim to fame.
You know, it's interesting, Larry. I don't know if you've ever heard it, but I've heard it from a number of my clients. I mean, I could get them to write testimonials. They sleep better. They feel better. Most of them say they either have returned to dreaming or dream better.
Never heard this one.
Because they sleep so much better. I actually have one client, they have 2 houses. One that's a high performance home, has a Zehnder in it. The other one is a not so performance home, has the bath exhaust fan. The wife hates living in that one. She wants to go to the mountain retreat all the time in there. She goes, Steve, I sleep better. I can work out all day, go snowshoeing or whatever, come back. I feel reinvigorated every morning. I dream through the night. She's had friends stay over that said, I don't know what it is about your house, but I just sleep so good here. So I know it's a small sampling, but I have at least a half a dozen clients that would attest to their house is the best climate they know.
Well, I have one little thing to add. I've lived in a house with a Zender now for 4 years. It is dust-free. My house is 100% dust-free. The only dust I've ever seen is on the leading edge of my ceiling fans. A little bit of a white powder, don't know where it comes from, but that's it. There's no dust on the TV screen from static electricity. There's no dust. I do not have to dust my house. So I know it's the Zender, but you know, I'm a little biased.
I gotcha. So air comes in, goes through the core, goes out to the house. Now we talked about what I call the distribution box over there, but I know we have a couple installed over here. You can see them here, and the high-tech labeling, so we know which one is going to the house.
Well, these are embossed with arrows.
Yeah, well, that's just telling me the direction of airflow. It's not really
gotcha.
telling me if it's going inside or outside. But here we have it. We have our pipes that come in to the box, and then these are 8-pipe distribution boxes here. So we have 8 going out here that are going to supply the house, obviously 8 different locations. We have our Comfo tube. You can see that just basically click and locks in there. And then we have the ability to snake it through the house. And then our return is going to come back from our return locations, go into here, go into the big pipe, go through the system, and get ejected out the side of the house. And here we have one pipe, our ejection system's out the side of the house there. Our supply is out here. Our displacement's on the order of about 30 feet. So we're good to go with that. Any parting words?
It's a privilege to be able to work with you guys and appreciate it. This is a very unique home, and customer's very lucky to have, it'll probably be one of the most comfortable houses I've ever seen.
This is, yeah, I'm excited to return here just to see how it's performing and get the stories year after year and see if Scott and Jonathan dream better and sleep better. So maybe we can add them to that testimonial list.
I'd love it.
There you go.
Thank you.
All right, well, there you have it. I told you, Larry, not only is Zender a great company, I've never met any employee from the Zender system that I just didn't have a fun chat with and I didn't learn something from. So anyways, get out there. These reps are out there for pretty much every material you use on the house. If you're an architect, a young builder, if you're an old builder that thinks you know everything, you need to talk to these guys even more, because chances are you're set in your ways and you need to have a conversation about what's up and coming. So anyways, go check it out. If you haven't checked out the previous episodes here on Build Show Build Boston, I suggest going back in time, check those out, come up to speed. We're up here, we're talking about HVAC. Hey, Steve Baczek, Architect. We're back at the studio here. Hopefully you appreciated that. Nothing better than walking around a job site, talking with the trades and talking with the professionals about how are we going to make this the best possible project that we can. So broke out some plans here. I figured we'd just run through the HVAC schematic conceptually about what we're thinking, as well as the you can see it's already somewhat pre-marked up, and Zender did that for us. We did a walkthrough with their reps and, walked and talked about different aspects of trying to supply and get some extraction from different areas. And so they put that all together into a drawing, sent that out to us. They're going to be out there, when the mechanical guys are going to be out there, but we can at least talk about the strategy here. So anyways, you can see we have our floor plan. Again, garage, utility area, living space, bedroom wing. We are actually going to have 2 Zender units. We'll have one downstairs here. Actually, we should just jump to the basement here. So we'll have one, they call it an East ERV there, and then we have west ERV here. So the west ERV, the plan is that this will take care of all of the bedroom wings as well as this bathroom and the retreat space office above, only because we're going to have this main trunk that runs through here, so we'll be able to capture that and tap off of that quite easy. The second unit, the east ERV, is going to basically be taking care of the utility space and or the living space here, as well as the recreational space below. And you can see that, the blues are measured in, or the supplies are in blue, the extractions are in red. Now, one of the things about both of the units, you need the supply and the exhaust. And we're going to have one go out one side, one go out the other. They need to be a 10-foot minimum in distance. You don't want to get what's called re-entrainment, where if I put a vent there and an exhaust vent there and an intake here, that I get that exhaust air simply being re-entrained into the system. So they have that requirement of a minimum of 10 feet. They really like to see them on opposing walls, rather than, even if you had one here, you had one here exactly 10 feet. They'd appreciate it if it was around the corner or down the wall even more. The one here, we will actually punch out here, and then we'll sneak down here and we'll do a second one on the back side there. So we met their 10-foot minimum for the ventilation requirements. And as far as mechanical goes, we have one system that is going to be here. I'll just put AH for our air handler. And the thing to remember about our mechanical system is we have, in all of the spaces in the basement, we have warm board going in as our heating. It's a radiant floor heating system. You saw when we did the floor framing video. If you haven't, go check that out. But we have more to come on that as we install those systems. But we're doing their retrofit panels down in the basement, which are their 3/4 inch panels. And then we already have their 1 1/8 panels that are installed upstairs on the first floor that are just waiting to receive the pipes or tubing. So the air handlers here are basically to just supply air conditioning. So we basically have this one that'll run a main trunk down there, and it'll run a main trunk down here, pretty much to about the end of the wall here. It'll be a pretty wide soffit that we'll have through here, and then we'll just narrow up a short soffit along the wall. And that's basically to take care of, we'll have a drop in the mechanical space there just to temper it. We have the fitness room, bedroom, and bathroom here, so we can jump off of that and solve for that. But remember, we have those bedrooms up above, so coming all the way out here allows us to jump in those joist bays. And if you remember when we went through the framing plans, if you haven't watched the video on where we talked about framing, but all of the floor framing along this side of the house is spanning in that direction, and all of the floor framing through the middle of the house here is spanning in that direction. And that was somewhat intentional, knowing that we would have that drop soffit down through here. Remember, we did a 9-foot basement there. Go check out the concrete basement video. But that allows us to tap in and jump up into those floor joists and capture the bedrooms and the bathroom up above here very easily, as well as tap off of this side and get into this bathroom as well as the retreat above. On this side here, just like with the ventilation system, we will have another air handling unit here that will have ductwork that goes here, and it goes about to there, and then this one will run across here. And because the floor joists are spanning in that direction, it'll allow us to pop up into that floor joist system and basically service the room above, surface the rec room here, have a drop to condition the dirty basement number 2 and have a drop to condition the dirty basement number 1, but also service the mud room, the laundry room, the powder room, the pantry. And we're not going to service the plant room. The plant room, just because it is south facing, so it's going to get, with some big glazing, it's going to get slightly different conditions there, as well as the plants and the moisture and such in there. We've determined that that's going to be on its own mechanical system. So we take that out of the picture and out of the scope of work for this air handler. So that's our basic strategy here with the mechanical guy. And as you can see upstairs here, we talked about having that duct that's going to run off there, feed all of the bedrooms, feed the retreat space, and then you can see, just like Zehnder has blocked it out, this section will be under its own, except for this. We'll have a unit, Mitsubishi unit, in the ceiling soffit there that'll blow in and take care of the plant room. The other thing that we have going on here is we actually are going to have what I would term a semi-conditioned garage. We're actually going to have a wall-mounted unit here, one of the Mitsubishi heat pumps. And that's basically just to take the edge off and provide a tempered garage there for the homeowners to use in the winter months. So anyways, very exciting stuff going on. All the mechanicals, these walls are getting filled up, and it won't be long, and we'll be talking insulation. So anyways, that's the concepts of HVAC. Remember, there's the V in that HVAC, right? So many people forget about it. So many people will argue against it, saying, oh, you don't need that. But remember, V, and it stands for, I know. I was told once, if I spell things out in the drawing, people will remember it because they'll get that visual memory of me spelling it out. But the V stands for ventilation, and it is definitely part of your control system. So until next time.